When our system is given to us and it's not in triangular form, we need to get it there. So some of the rules that we have, we multiply entire equations by non-zero constants. We can multiply an entire equation by a non-zero constant and not change its value. We just change what it looks like. We can interchange the order the equations are listed in. And we can add a multiple of one equation to another. What we cannot do is we cannot just add a constant to a term in an equation. So we cannot do that. So let me demonstrate. We have equation 1, equation 2, equation 3. My goal is to eliminate a variable. So my goal is to pick two equations and eliminate a variable. So we want to eliminate one of the variables. So do I want to eliminate x, do I want to eliminate y, or do I want to eliminate z? Well, I'm going to take equation 2 and 3, just so that I can show you that I can interchange the order of equations in any, I can pick in any order that I want to. So I'm going to pick equation, actually let me pick 1 and 3. I'm going to pick equation 1 and equation 3. And I'm going to eliminate the x's. So I'm going to choose to eliminate the x's. So eliminate x using equations 1 and 3. So equation 1 is x plus 2y plus z equals 3. And equation 3 is x plus y plus 2z equals 9. Now I can add or I can subtract the equations from one another. I think everyone's used to adding, so what I'll do is I'll just keep it comfortable for everyone. I'm going to multiply equation number 1 by -1. So we're going to multiply by -1. That's going to give us negative x minus 2y minus z equals -3. Now what I've done there is, you can see I've multiplied. So I multiplied an entire equation by -1. Now what I'm going to do is I'm going to add equation 3 with the new equation 1. So that's the new equation 1. So I add those two together, the x's cancel, I get -y plus z equals 6. And I'm going to call that equation 4, so that it creates a new equation 4. I'm going to come over here and I want to eliminate x. So I need to eliminate x again, but I need to use different equations now. So which two equations might we want to use to eliminate x? I'm going to use equation 1 and equation 2. I could use 2 and 3. It really doesn't matter, but I'm going to pick equation 1 and 2. I just can't pick 1 and 3 again because I already know I'm going to get -y plus z equals 6 if I pick 1 and 3. So I have to pick two different equations and eliminate the same variable. So equation 1 is x plus 2y plus z equals 3. Equation 2 is 2x plus y plus z equals 16. I'm going to multiply equation 1 by -2. So that's going to give me -2x minus 4y minus 2z equals -6. And now we will add equation 2 and the new equation 1, right? The new equation 1. And that gives us -3y minus z equals 10. And that I'm going to call equation 5. So we pick two equations and eliminate a variable. Pick two different equations and eliminate the same variable. So I'm going to color code this for you so that you can see, because it's a really simple process. And I want you to have some notes here to follow. So this was the first step. We picked equation 1 and 3, eliminated x. And then we had to pick two different equations and eliminate the same variable. So since we eliminated x, we're going to eliminate x again. And this time I picked equations 1 and 2. Now what we do, this is some cool stuff right here. So now we went from 3 equations with 3 variables to 2 equations with 2 variables. So now we can take these 2 equations and we can consider them together, and we want to now eliminate one of the 2 variables. Well, in this case, it's going to be easiest to eliminate z because I have positive z and negative z. If I add the 2 together, the z's naturally cancel out. So what we're left with is negative 4y equals 16. This is a 6th new equation. So you can see that we went from equations with 3 variables to equations with 2 variables, right? 2 variables, to now an equation with just 1 variable. Now we can solve for this 1 variable and work our way backwards. So we're going to divide both sides by negative 4, and we get y equals negative 4. So in my ordered triple, x, y, z, y is negative 4. Now I can take that y equals negative 4 and I can plug it back into either equation 4 or equation 5. I'm going to plug it into equation 4. So equation 4 is now the opposite of negative 4 plus z equals 6. 4 plus z equals 6 makes z equal to 2. Now that I have y equals negative 4 and z equals 2, I can take both of these values and plug it into one of the original equations with 3 variables. I'm going to take x plus 2y plus z. X plus 2y plus z equals 3. That was our very first equation. This is the original equation 1. I'm going to put y equals negative 4. We're going to put this value in for y, and I'm going to put this value in for z, and you'll see that we're going to be able to solve for x. X plus 2 times negative 4 plus 2 equals 3. X minus 8 plus 2 equals 3. X minus 6 equals 3. X equals 9. That fills in all of our values in our ordered triple, and we get 9, negative 4, and positive 2 for our answer. X equals 9, y equals negative 4, and z equals 2.